joining us in Mathcon universe and the wonderful world of mathematics. Today we're going to focus on strategic problem solving in key concept of algebraic inequalities. Strategic problem solving in key concept of algebraic inequalities. And today we're going to examine a problem connected to what we call linear algebraic inequality. Linear algebraic inequality. And we are going to use strategic problem solving to break down this type of problem. So what will be our first step in this strategic problem solving process? Our first step is to use distributive property. Distributive property. So let us remember that this will be then the first step in this problem solving process. Step number one, using distributive property. How does distributive property work? How does it work? Let us see. If you have A into B minus C, where A, B, and C are any real number on the real number line, then we can write this as what? A times B minus A times C. In our problem, we can then be able to write this problem as negative 2 times 3x, negative 2 times 3x. So what will be negative 2 times 3x? That will give us what? Negative 6x. So using strategic problem solving, and of course, step number one, using the distributive property, we are able to write this problem as what? Negative 2 times 3x. And then we're going to do negative 2 times negative 4, which will give us what? Positive 8. Positive 8. What will be our next step in this problem solving process? Well, our next step will be to bring down the negative 10. And then bring down the inequality symbol and then the number on the right side of the algebraic inequality. What will be our next step in this problem solving process? Our next step will be to combine like terms. To combine like terms. To combine like terms. Step number 2. Step number 2. Combine like terms. So what is the like term in this problem? Like term, of course, is the 8 and the negative 10. What is positive 8 minus 10? Positive 8 minus 10 is going to be a negative 2. Negative 2. So therefore we bring down the negative 6x. It becomes minus 2 greater than 20. So what will be our next step in this strategic problem solving process? Our next step, of course, will be to move the negative 2 to the right side of the inequality. Move the negative 2 to the right side of the inequality. Because we want to isolate a quantity with x by itself. We want to isolate it from every other quantity in this problem, so we can solve for x. So therefore, we are going to move the negative 2 to the right side. Notice when you move any quantity across the equal sign or inequality sign, you are going to change the sign of that quantity. I repeat, when you solve algebraic equation or whenever you're solving algebraic inequality, whenever you move any quantity across the equality symbol or inequality symbol, the sign of that quantity must change. Therefore, our negative 2 becomes a positive 2 at this point. So we have negative 6x greater than 20 plus 2. I repeat, we have negative 6x greater than 20 plus 2. And therefore, this problem becomes now negative 6x is greater than 22. Negative 6x is greater than 22. At this point, what must we do to finish the problem? Or at least to come close to finishing the problem. What must we do? Well, we need to divide both sides of inequality by negative 6. But keep something in mind. Keep something in mind. Don't forget this. Do not forget this. Anytime we divide both sides of an inequality by a negative quantity, the symbol of that inequality must change. The inequality sign or symbol must change. So consequently, we divide the negative 6x by negative 6, and of course the 22 by negative 6, because whatever you do to one side of the inequality, you must do to the other side. By dividing the left side of the inequality by negative 6, we must do the same thing to the right side of the inequality. However, something has changed drastically. What has changed? This inequality symbol is reversed. So instead of greater than symbol, we now have the less than symbol, because we have divided both sides of the inequality by a negative quantity, namely negative 6. So therefore, we can now cancel out the negative 6 here, and we just obtain 1 and 1 here. So consequently, we now have x is less than negative 22 over 6. Negative 22 over 6. So what is negative 22 over 6? How can we break this down further? Notice, this now is the same thing as what? Taking the 22 and try to divide it by 6. So let's set aside the negative quantity for 1 second. Or 2 seconds. Notice, 6 will go into 22 how many times? 3 times. Is that true? Yes. Is that true? Yes, indeed. 3 times 6 is what? 18. And then, what is 22 minus 18? 22 minus 18? You can borrow 1 from here, and of course you have 12. 12 minus 8 is going to be 4. And of course you have 1, and 0 here. So therefore, 22 minus 18 is 4. So what are we going to do next? We can now be able to go ahead and try to decimalize this, or we can fractionalize this. If we need to fractionalize it, this becomes what? 3 into 4 over 6. But 3 into 4 over 6 is the same thing as what? 3 into what? 2 over what? 3. 3 into 2 over 3. Because there is a common factor between 4 and 6, namely 2. 2 can go into 4 2 times, 2 can go into 6 3 times. So notice, we must not forget our negative sign. So therefore, the solution here becomes x now is less than negative 3, 2 over 3. How do we represent this on a real number line? Let us see. How do we represent the solution on a real number line? Let us see how we can go about representing the solution on a real number line. Or what we could call graphical representation of the solution. So this is one form of the solution, but now we must try to represent this graphically. Notice on the real number line, the number 0 is the middle number between the negative numbers and what? The positive numbers. So notice, if we pick the number 1 on the right side, and then of course the number 2, the number 3, the number 4, and so on and so forth. And on the left side, we can now pick the quantity negative 1, negative 2, negative 3, negative 4, and so on and so forth. So how do we represent the solution? Notice that this solution must be between negative 3 and negative 4. Negative 3 and negative 4. So negative 3 and 2/3. Where would that be? So negative 3 is here. And for sure we know that we can be able to note that this quantity here will be negative 3 and what? 1/3 here. And then the negative 3 and 1/3. And right here, we will have then the negative 3 and 2/3, which is closer to negative 4. So therefore, to represent this solution graphically, it might be a good idea to extend our line a little bit. So we have our negative 4 here. So our negative 5 should be appropriate here. So therefore, everything to what? The left. Everything to the left of negative 3 over 2/3 will be a solution to the inequality. Notice, negative 3 over 2/3 is not a solution, but everything less than that quantity is a solution. So let us quickly go over this problem one more time. Step number 1, we used distributive property. And by using distributive property, we were able to obtain negative 6x plus 8 minus 10 greater than 20. After simplifying the problem, we were able to obtain negative 6x greater than 20 plus 2. And of course, we were able to then obtain the fact that negative 6x is greater than 22. But notice, the goal is to solve for x. So therefore, we must divide both sides by -6. However, because we're dividing by negative quantity, we had to revise the inequality. And then we're able to obtain that x is less than -22/6, which is the same thing as what? -3 2/3. Of course, finally we went on and graphed this solution, and this is what we call the graphical solution. The graphical solution of the problem. Okay, it's a regular solution, and here is the graphical solution. And I hope that you have learned something about how to solve a linear inequality problem using strategic problem solving approach. And I hope that you will continue to practice on this type of problem more and more. Practice solving this type of problem more and more. And the more you solve this type of problem, the more you will increase your problem solving confidence. Until next time, thank you so much today for joining us in Mathcon Universe and the wonderful world of mathematics.